And we're rolling. Okay, today is section 1.1. So, what is the formula for the circumference of a circle? 2 pi r. What is the formula for the area of a circle? Pi r squared. How do you tell them apart? Well, a radius is a length. It's one-dimensional. It only goes one direction. Okay? And which means that this number is one-dimensional. Right? 2 times 3.14 times 3 is going to be in inches. My answer will be in inches, and the circumference of the circle is measured in inches. But area wants to know how much room does this take up, and when I do pi times 3 inches squared, then I'm going to get basically 9 pi inches to the second, because I squared the inches. So the way I remember area is pi r squared is area is in square units, and so we have to square the radius. Can you guys remember that? Okay. So this first question wants to know, a company makes paper labels for paint cans, and we have a cylinder that is 4 inches tall and has a radius of 3 inches. How much area or how much paper will the company need if it wants to make 19 labels for these cans? Okay. How are we going to make labels for this can? What shape will the labels be? They're going to be round. Do we have a printer that can print round labels? No. So how are we going to do that? We're going to print it off as a rectangle and then wrap it around the can. So if I were to cut the label and fold it out, it's going to look like this. What will its dimensions be? The height will be 4 inches, and then this distance here is going to be this distance here, which is the circumference. So it wants us to use 3.14. So C equals 2 pi times 3. So 2 times 3.14 times 3 is 18.84. How do I find the area? Multiply that by 4. So multiply those together, and I get 75.36 inches squared. What does that mean, inches squared? It's the area, but why square inches? Why not 75 inches? Inches is a length. Good. So what does having 75 square inches mean about this label? Okay, so the shape is 75 inches squared. Oh, you said the wrong word. If you have a square, that's an inch by an inch. So if I were to cut this up into 1 inch squares, I would have 75 and about a third of them, if I counted them, right? 1, 2, 3, 4, 5. So this area is equivalent to 75.36 squares that are 1 inch by 1 inch. That's what it means. Okay, is that the answer? What does this tell us about the problem? That's the area for one label. How many labels am I making? 19. So I times that by 19 and I get 1,431.84. Okay. Now, What if it told me I have 3,000 square inches of paper? How many labels can I make? You would take 3,000 and divide it by 75.36. And I get 39.8. So what's the answer? 39. Why not round it up to 40? I don't have enough paper. Okay? So even though 0.8 is bigger than 0.5, I'm not going to round it up because I don't have enough paper to make that last label. Okay? Good job, guys. So next problem. This one deals with population density. What is density? Okay, so in this case, it could be people per square mile. If I was talking about the density of wood or a rock, what am I talking about? How much weight is in a certain volume? Which has a higher density, rocks or wood? Rocks. How do you know? How do we test density of rocks and wood? Throw them in water, right? Wood floats. Most wood floats. If you go up on the mountain and you cut a piece of mountain mahogany, it sinks, which is weird. Really, really hard and heavy wood. But so density is how much something weighs for how big it is. Okay? In this case, we're talking about population density, which means how many people are in a certain area. So a map of a city shaped like a rectangle is given on a grid below. The population was 990,000 people. What was the population density? So this is 55 kilometers by 50 kilometers. So what should I do? So 50 times 55 is that many kilometers squared. And I divide the number of people by that number. So 990,000 divided by the answer. And I get 360 what? People per kilometer. So this city has a population density of 360 people per kilometer. Oh, kilometer squared. Is that a lot? 360 people per kilometer squared? If it was in miles, it'd be easier for me to figure out. It's probably pretty dense. More dense than Castledale, I would imagine. Okay, does that mean that every square kilometer has 360 people in it? That's the average. So 1 kilometer might have a high-rise building, and it has more density, and then right next door is a house, and it's not as tall, it can't hold as many people. But on average, every square kilometer in this city has 360 people. Any questions there? Okay. All right. How do we find the surface area of a rectangular prism? Well, we find the surface area of this, which is going to be, so it's 7 meters long and 2 meters high, so that would be 14 meters squared. And then we find the area of that, which is going to be 12 meters squared. And then we find the area of this, which is going to be 42 meters squared. And you'll notice each one of those shapes has a duplicate shape on the other side of the cube of the prism. So should I times them all by 2 and add them together? Or should I add them all together and then times everything by 2? Does it matter? No. So whether you do this or whether you do this, you're going to get the same answer. Okay? Yep. Okay, surface area of a cylinder. So in the last cylinder problem, we were just calculating the area of the label. And in this case, we want to know how much area does the entire can have. So let's say that we're making these out of steel. We wanted to know how much surface area does the steel have. So we need to find the surface area of the section that's covered by the label, which we already know is just going to be 5 times the circumference. And the circumference is 2 times 3.14 times 2. Okay, so the 5 is this side of the label, and that is that side of the label. So 5 times 3.14 times 2 times 2 is 62.8 meters squared. Now what? Have to find the area of the lid. And area is pi r squared. So 3.14 times 2 squared. So the top is 12.56 meters squared. Now what? Then the bottom is going to be exactly the same size as the top. So I will double the top and then add that number to this, and that will be my total surface area. I keep forgetting. And I think we've already done, let me look. Yep, we've already done one of these. Okay, 1.1 on Alex. Get to work.